Hey everyone, welcome to the second video covering group bys for Pandas Python. So in the previous video, I introduced group bys with two simple examples and simple aggregations. So now we're going to actually dive deeper into explaining more things you can do with group bys. And so I'll introduce more complex functions that you can use to apply to your data. So it's best if you follow along with me by downloading the Python notebook that I have linked below. You can open up that Python notebook in either Jupyter Notebooks or Google Colabs. As you can see here, I have it opened up in Google Colabs. Also, if you're completely new to Pandas or completely new to group bys in general, I suggest you look at and watch the first group by video that I have in the link below. That should help you kind of catch up to where we're going to be in this video. All right, so let's get started. So if you are following along with me, you've downloaded your Python notebook, opened it up, and you're basically seeing what I have right now, right? And so what I want to do is just make sure that I have this run. This function is essentially a function that will allow several things to be displayed side by side. So we're going to use this display function if we want to just display several outputs side by side to compare them. All right. We're going to skip all of this, like the beginning of this notebook, because it's actually the exercise that we used or we did in the previous video. So again, if you're completely new to group bys, go ahead and watch the previous video before this video first. Get caught up with us, and then we can dive into more complex concepts. So let's go over the first method we're going to explain. This is the aggregation method that we can use on group by objects. So let me just give you a very simple aggregation example. So if we took the data frame df and we basically apply a group by on the key column, if we wanted to do a simple aggregation on, say, data 1, and maybe we just wanted to take the median, we can simply do that, right? It gives us the keys, it collapses the keys, and then it takes the median of the keys. And that makes sense because these keys here are duplicated twice. So it has 2 rows, B has 2 rows, C has 2 rows. So it's basically taking the median once it collapses them. All right, that's great. But what if we wanted to essentially take multiple aggregations at the same time? So we wanted, for example, to get the median, but also let's say we wanted the min, right? And let's say we wanted to take the max. Can we do that all at once? Or do we have to actually write 3 lines of code? So this aggregate method here that you're seeing that I'm highlighting allows you to take multiple aggregations at once. So all we actually need to do is let's just start with the key column, the group by, and then the key column as our categorical column, and then apply this aggregate method here. And then inside the parentheses of aggregate, I'm just going to type in the aggregates that I want, the mathematical operations that I want. And I'm going to write them like this. So it's going to be in a list, so I need brackets. I'm going to have 3 aggregates. So the first one will be min. Second one will be median. And then the last one will be a max function. And I have them all kind of written out in different ways. And that's because of this line I wrote here, that this like min, median, max could be written in any way. It could be written as a string, as you see here. It could be written, using like calling in the NumPy library. And it could be written in as essentially a function, right? And so there's so many different ways of actually writing the aggregate that you want. The pandas or this group by concept will take each and every one. And so here's a quick example. And this is what we get. We basically get the min, the median, and the max all at once for both data columns as well. So that's just one line of code, and it gives us basically 3 different aggregates. So another thing we can also do is, if we don't want all of this data, for example, we can actually pass in a dictionary to basically explicitly call out the column we want and the aggregate we want. So let me just show you really quick what I mean by that. So I'm going to take the data frame df, I'm going to apply the groupby function to the key column, and I'm going to call the aggregate method here, and then I'm going to pass the dictionary like I mentioned before. So I'm just going to create a new line here just to make things look a little easier. I'm going to call the data column data1, and for data1, let's look at data1 here. I'm just going to, maybe I'm interested in just like the min, right? The minimum number when I collapse this and when I do a group by. So that actually should give me a 0 for the data1 column, right? And then the minimum for key A for data2 is 3. So these are the numbers I'm thinking about when I'm double checking whether or not I got this right. So now I'm going to do the same thing for data2, but instead of the min, I'm going to ask for the max. And then I'm going to just tidy this up a little bit so that the syntax looks good and I can read it well. And so that's essentially the dictionary I'm passing. It has columns and it has the mathematical operator or aggregate that I want to apply to the data column itself, or to the column. All right, so if I run this line of code, I get the group by, the keys collapse just like I'm expecting. So the key column is all unique values now. And then the data one column has the minimum value that was found in the original data frame here. All right, 0, and then for B it should be a 1, and then for C it should be a 2 because 2 is less than 5. And then the opposite is true for data 2. So actually, if you go and just take a look at the original data frame yourself, it should actually match up to these numbers here. And so that's an easy way to, essentially do multiple aggregates and explicitly call the column that you want and apply that specific aggregate to a specific column. All right, so now let's go into covering the filtering method as applied to the groupby function. The filtering method allows you to drop data or rows of data based off of logic that you write. So in this example that I'm going to write up, we're going to be keeping all groups in which a standard deviation is larger than some critical value that we designate ourselves. Right? So what I want to do is just output what that original data frame looks like. All right, so again, we have 3 columns. We have a key column and we have 2 data columns. And then what I want to do is I'm going to apply the groupby function to the key column, and I'm going to just take the standard deviation of both data 1 and data 2 columns. And so what I want to do is I want to write a function where I keep rows of data that's larger than a standard deviation of 4. So 4 is just an arbitrary number that I picked because I'm looking at this data right now, and 4 will allow me to keep rows B and C because they're much larger than 1.4. All right, and so this will be obvious in about a second when I write this function. I'm going to write a function called filterfunc. So what I'm going to do is I'm going to take the data2 column, and then I'm going to apply the standard deviation function to the data2 column, and I want to compare it to the standard deviation of 4. So for this to be true, the standard deviation of the data 2, whatever data 2 value there is, needs to be greater than 4. This will only be true for rows B and C. So that's important to note, and I'll just write it. Function is true for only B and C, so A will be removed. All right, or let's say A is false. That's a more accurate way of explaining what this function does. All right, so after that, now I want to apply the filter method to the group by. And what I can do now is I'll take the data frame, I'll take then the group by to the key column, and then I'm going to apply the filter method. And then inside the filter method parentheses, I need to put in what my logical statement is, right? So basically what I'm saying is, what logic do I want to apply to my data set? Like, how do I want to filter out rows in my data set? How do I want to filter out rows in my data frame, right? The logic that I want is this, right? I basically just want to keep rows where the standard deviation of data 2 is greater than 4. So I'm going to copy and paste this filter function here and put it down here. And so I want to make sure I run this line of code up here. And then what I'm going to do is run this filter function line of code. And I basically get only rows B and C, which is what I wrote up here, right? For this function to be true, it's going to be only true for B and C, and A is going to be false. So this filter method here actually removes A from the resulting output, right? And so what I can do also to just illustrate things a little bit easier, I'm going to use the display function. That display function was at the very top of this Python notebook. So run that line of code if you haven't done so yet. This will allow us to display output side by side. So I actually want to display this output. I'm going to, instead of using single quotes, I'm going to use double quotes because there are single quotes in this key, this like right here. So I don't want I don't want Python to be confused and mess things up. So I'm going to use double quotes, and I'm going to use double quotes for this line of code as well. And so what I should get is 3 outputs. So I get the original data frame, which has basically, 3 keys, A, B, and C, and then again, A, B, and C. It has the standard deviation. And you can see that rows B and C for data 2 column, the data 2 column, rows B and C has a standard deviation of above 4, which is basically my logic here. And so when I apply this logic of only wanting to keep rows where the standard deviation of data 2 is greater than 4, what should come out is really only rows B and C. So that's what I get here. B and C and B and C. B and C, B and C, and then rows A are basically filtered out. All right, and so that's how you apply the filtering method to a group by to basically filter out rows of data that doesn't meet your logic. So next, let's look at the transformation method or the transform method. So the transform method essentially allows you to perform some sort of mathematical operation on the entire data set. So what you're going to get is you're not going to get a reduced number of rows. You're actually going to get the same shape as the input. So if you had 6 rows as the input, 6 rows in the data frame, you're going to have 6 rows as the output. The only difference with transform is that you're going to be able to apply some sort of mathematical operation on each row based off of whatever it is that you want to apply to that data frame. So what we're gonna do is this example here, we're gonna center the data by subtracting the group wise mean. And so I'm gonna show you what that means and what that looks like. So we're going to take the data frame here. And again, let me just display what the data frame looks like. The original data frame looks like this. I'm going to take the group by function and put in the key column. And then I'm going to use the transform method. I'm going to use the lambda function here so that I take a mean of the row, or I subtract the row value by the row mean. So let me explain what's happening here. So basically what this lambda function is going to do, it's going to go row by row, and it's going to take the mean. It's going to take the value, it's going to take the value that it sees here. So for example, 0, and it's going to subtract 0 from the group mean. And what the group mean is basically taking the mean of both of these A columns here and then subtracting 0 from that mean. Okay, so we're going to actually work on this. We're gonna actually work on this manually after I run this line of code. So I'm getting this output, right? And so the transform, like I said before, if I had 6 rows in the original data frame, I'm going to have 6 rows in the output data frame. But basically, we can do the math here just to illustrate what transform is actually doing, right? So I care about these mean first because I'm subtracting my an original value from by the mean. So what I'm going to do is I'm going to calculate the mean, the group Y's mean. So just for calculating data 1, the data 1 column here, the group Y's mean for A would be 0 plus 3 divided by 2, right? Divided by 2 because there are 2 rows of A. So that would basically be 1.5. So A is 1.5. And then B would be 1 plus 4, which is 5, divided by 2, which is 2.5. And then C, same calculation, 2 plus 5 is 7, divided by 2 is 3.5, right? And so let's do the same thing for data 2. So I'll go over that again very slowly. For A, it is 5 plus 3, which is 8, divided by 2, which will be 4. And then for B, it will be 0 plus 7 divided by 2, which is 3.5. And then for C, it's 3 plus 9, which is 12, divided by 2, which should give us 8 or 6. All right, so that's the group Y's mean. And I'll say group Y's mean. So now what we're going to do, and maybe I'll just do this for the first 2 rows, is I'm going to apply x minus x mean, right? So what does that look like? So what that means is for row 0, this first row right here, for data 1, it's going to look like this. It's going to look, the calculation is basically going to be 0 minus the group Y's mean here, which is 1.5, which is going to lead us to negative 1.5, right? Which is exactly what we get here. So then for data 2, same calculation. I'm going to now take 5, subtract that by the group mean, which is 4. That should equal 1. That's what I get here, right? So let's just do this for one more row. Let's do this for the second row. Data 1. So data 1, the original value is 1. Subtracted from the mean, which is, let's see, for B, which is 2.5, right? That gives us a negative 1.5. Data 2, which is here for row 2, which is 0. So that's the original value, which is going to be 0. Subtract that from the mean. The data 2 key of B mean is 3.5. 0 minus 3.5 is negative 3.5. And that's what I get here too. So just doing these calculations for the first 2 rows, I get a negative 1.5, which is what I get here. I get a 1, which is what I get here. I get a negative 1.5 when I go down to the second row of data 1. And then I get a negative 3.5 for data 2 in the second row, which is what I get here. So if you do that for the remaining rows, you'll get the exact same thing. This is what transform allows you to do. You're able to do some simple mathematical operation, but it's rather complicated because you're taking a group-wise mean, right, in this example here. So if you were to do this like step by step without using the transform method, it will take you much, much longer. You're going to have to actually manually calculate out all the means for each group and then apply the means. And it's going to take several lines of code. But this transform method in conjunction with the groupby function allows you to do this, do this simple mathematical operations very quickly with one line of code. All right, so now let's talk about the apply method. So the apply method allows you to apply a arbitrary function that you write yourself to the group results. So I'll explain what that means. But basically what we're allowed to do with the apply function or apply method is create a logical statement like a mathematical operation, create your own function, for example, and then apply that function to every row in your data frame. So let's look at what that could possibly mean. So I'm going to output the data frame again. This is the original data frame. And I want to, for example, normalize the first column. I want to normalize data 1. So I'm going to write a function that allows me to do that. So I'm going to call this function norm by data 2. And again, what we want to do is normalize the column data 1 by values that we get in data 2. All right, so in order to do that, I'm just going to take the value of data 1, divide the values that I get in data 1 by the sum of data 2, right? And that's essentially how I'm going to normalize it. So for those that don't write a lot of code in Python, you may not know what this operation does. This is basically the same thing as saying this right here. I'll just put this in the comments here. It's basically saying, do this mathematical operation. So what I'm going to do is I'm going to take the value I get in data 1 with divide that by the sum of the values that I get in data 2. So take data 1 divided by the sum in data 2 and save it back into data 1, like overwrite the value and save it into the data 1. The reason why I just use this, the slash and the equal sign, is that it saves me for having to write this again, right? There's just less duplication, makes it a little easier, but it also makes it a little bit more confusing because it's a little bit abstracted out, right? So it is what it is. I will keep both of these lines of code work, so you can use whatever you want, whatever is easier for you. I'm going to end the function by returning x. All right. And so I'll just run this line of code here. And then what I want to do is I want to use the apply method now and then use this function with the apply method. And I'm going to do that by basically writing and taking the data frame, grouping it by the key column, using the apply method, and then inside the apply method, you need to basically write how you want to apply your logical statement to the data frame. And I'm just going to take norm by data2 right here, and then I'll run this line of code and I'll get my output, right? And so this could be a little confusing for you. How do I know that this function was applied, and how was it really applied, right? That's probably the most important question that you have, is how was it actually applied? So let me clean this up really quick, and then we're gonna manually go through the math of this all. So I'm going to use the display function again, display the original data frame, and then display this resulting data frame so that we can see things side by side. And now let's just go through the math manually for the first maybe 3 lines of code or 3 rows of the data frame. All right, so the first one's really easy because this is row 0, which is here. And the only change that we see in this resulting data frame is data 1, right? So that makes sense because we're only overriding values in data 1, as you can see here. So only data 1 will be changed. So for the first row, row index 0, basically we're taking the value 0 and dividing it by the sum of data 2. But it's a group-wise sum. So I'm taking A, so 5, plus the second row, the second time I see A, which is going to be in data 2, which is 3. So 0 divided by 8 equals 0. So that's not like the best example to show, right? I see a 0 here. So let's just take the second row, the row index 1. The data 1 value is 1, so I have that. And then the data 2 value of the first time I see B is 0. I'm going to add that to the second time I see B. Data 2 value is 7. Now just take a calculator. 1 divided by 7 is equal to 1.142857. So that is what I get here, right? And so one more example. Let's take the third row, the 2 index, the key of C. Data 1's value is 2. So now we're gonna sum the data 2 values for C, which is 3 and 9. 3 plus 9, that should be 2 divided by 12, and that will lead us to 0.166667. So that's exactly what we get. So this is really simple. You're using the apply function, the apply method, to apply some sort of math operation that you want to define. And it's, usually a custom mathematical function that you're going to write, and you're going to just put that into the apply method like I did right here. All right. So the last few topics we were talking about basically splitting and grouping data based off of values in a single column. So if I were to display what df is, we went through exercises of introducing methods and functions that split and group data based off of this key function, right? Or this key column, I should say. So we split and group data based off of A, and then B, and then C. But what if we wanted tighter control? What if we wanted to specify our own way of splitting things, our own split key? So I'm going to show you how to do that. What I'm going to first do is I'm going to create a list with these values here. And basically what I'm doing is I am creating a list of how I want to split and group the data together, right? And so basically 0, 0, and 0 here is going to be split and grouped together. 1 and 1 here is going to be grouped together, and then 2 is going to be grouped by itself. So now what I'm going to do is I'm going to display the original data frame like I have right here. And then I'm going to group by this new key that I just wrote out. So I'm going to take, I'm going to take the data frame, I'm going to group by L, and then I'm going to take the sum of that. Right, so all that I'm doing right now is instead of grouping by this key column, I'm grouping by this L list. And I get something like this. So let's actually just run through the math really quick so I can illustrate how I'm able to specify how I want to split the data and how I want to group the data. All right, so let's just go through each of these rows here and figure out and calculate how I got to 7, how I got to 17, and so forth. So for the first row, the index of 0, data 1, so let's just do the math on this. So if I had the first row is a 0, the third row is a 0, and then the last row is a 0. For data 1, it's going to be 0 here, which is the first row, plus the third row, right? The third row is this one right here, which for data 1 is going to be a 2. And then the last row, which is a 0, is going to be a 5. That's going to equal 7, which I get right here, 7. So now let's do the same thing, but for data 2. So the first row is a 0, that's going to be a 5. The third row I'm specifying as a 0. Third row here, data 2 is a 3. The last row is a 0. The last row in data 2, the value is 9, so I'm going to put a 9 there. So it's 5 plus 3 plus 9 equals 17. So now let's do that again just to reinforce the calculation and reinforce this concept of basically being able to specify your own index, your own key. So for now, for the one position or the one index for data 1, I only care about the position 2 and position 4. So basically the row number 2 and row number 4. So for data 1, row number 2 is 1. And then row number 4 is 3. That should equal 4, which is what we get here. Now for data column 2, I only care again about the second row and the fourth row because the index is both 1. So that's a 0 and that's a 3. 0 plus 3 equals 3, and that's what we get here. And now just to complete this exercise, data 1, index key of 2, which is here, it's essentially the fifth row or the second to last row. That would be a 4. Second to last row for data 1 is a 4, which is what we get here. And then data 2 should be a 7 because that's what we get here, right? And so that's how you run, that's how you can essentially re-index it based off of what you want to specify. And then if you use the group by of your own index, it will split and group, essentially the values based off of the index that you just created by yourself. All right. And so the last concept that I want to essentially explain is the fact that you can just pass through any Python function in the group by method, and it's essentially going to work. And so I want to just show you what that looks like and what that means. So what I'm going to do is I have this original data frame df here. What I want to actually do is make this whole thing here, this column, I want to essentially make it a lowercase letters. So what I'm going to do is I'm going to set this index here, set this key column to the index. So the index is currently 1 through 5. I actually want the index to be A, B, C, A, B, C. So I'm going to set the index using this function. All right, I'm going to call this df2, and then I'll display it for you. So now I have two columns, two data columns, data 1, data 2, and I have an index of key, which is ABC, ABC. So now what I want to do is I want to take the mean. I want to do a group by and take the mean of essentially data 1 and data 2 and collapse these keys so that they're unique, right? And so we did this in the notebook. One of the first exercises at the top, you'll see something very similar to this. But what I'm going to also do is lower, make this key, all of these letters lowercase at the same time. So I'm going to take df2, which is this data frame here. I'm going to use group by. I'm going to use a string lower command, which is going to take this string and just make it lowercase. And then I'm going to take the mean. I'm going to take the mean of data 1 and data 2. And so what I get is exactly that. I get the mean, and if you do the calculation of, taking the mean of A from here and here, you will get these numbers. And if you do it for all of the other rows, you'll get the same thing. But more importantly is I'm passing through essentially this function or this method so that the letters go from uppercase to lowercase. And you can really pass any function you want in the group by, and it should be able to apply that to the data frame. All right, so that's really it for group by. We dove really deep into what a group by does and all the different aggregation techniques and methods you can use with group by.